Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's SecurityBoulevard.com webinar, brought to you by TechStrong and NewVector. My name is Cody J. Brown. I'm the host of TechStrong Learning. We have an exciting presentation ahead of us, but first I have a couple of housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion, whether you have to leave early or maybe you joined us late, the on-demand version will be made available shortly after we conclude our live webinar today. If you have any questions for our speakers, we want you to direct those to the Q&A tab on the right side of the screen. And we also encourage you to chat with us in the chat tab. Finally, at the conclusion of our webinar, we will be giving away 4 $25 Amazon gift cards, so be sure to stick around. So our topic today is Zero Trust Security for Kubernetes and Container Workloads. And I'm joined today by Fei Huang, Vice President of Security Product Strategy at NewVector, and Glenn Kosaka, Head of Product Security at NewVector. And it's my pleasure at this point to turn the floor over to Fei. Thank you both so much for being here with me today.
Thanks, Cody. Hello, everyone, and thanks so much for joining us. Basically, today we would like to share with you about what Zero Trust means for cloud-native environment. Right? Happy to get a chance to share with everybody what we see in the field when we're talking with our customers. We learn a lot from the community and from the customers, and today is a good opportunity for us to share the details of that. So before we get started, we're always thinking about, hey, what are the changes, right? What's happened about the infrastructure environment during the past years? So one big indication I saw is parameter is really changing, or you can call it is disappearing or even blurring. Because think about say 15, 20 years ago, right? When we start using virtualization technology to migrate the physical servers to a data center, suddenly we realize that, oh, that's the cloud, the foundation of the cloud technology. So you start to using virtual machines, load balancers, virtual storage, right? And suddenly, the power of the cloud, start to appear. So think about the security protections around that. Before, we all have all kinds of security solutions protecting parameters. For example, we have antivirus software installed on every laptop or desktop to scan your local storage file system on guarding the network. And we have network gateway firewalls. Today, even everybody's home have routers with built-in firewall capabilities, right? That's protecting your home as a parameter. But then, like in about like 7, 8 years ago, right? People protecting the cloud using the cloud security technologies, like they start protecting the virtual machines, virtual network, protecting load balancers, and have CDNs, right? Protecting all the traffic goes into the services. But suddenly container came out. Microservices changed the parameter again because this container, the big advantage of the containerization technology is be able to run your microservices anywhere automatically when the resource is available. That's a whole new way of utilization of the resource. So the new concepts, new parameter came out. Like what if you, how do you know about container network, all the microservice communications? How about the namespaces? How about my services, right? I run different services on the same physical server or same virtual host. And I have, port-to-port communication, and even more, the service mesh technology add another layer of virtualization on top, right? And you may have sidecars running side by side with your running pods. And you now have multiple clouds. Technology make the multiple clouds possible as well. We see many customers already adopting multiple clouds, right, to running their Kubernetes workloads. They connect their private cloud Kubernetes back to the public cloud workloads running some public, production grade services. So those cross-cloud, hybrid cloud environment requires much more complicated security around. You compare it to like 20 years ago, 30 years ago, first version of cloud technology. And even more, we also see serverless technology is rising up, and we see people checking the code into GitHub right away through the CI/CD pipeline. They deploy the serverless functions directly into the public cloud to become an enterprise-grade service. It's such a great distributed workload environment. But if you look at the security parameter, it's changing so fast and it's disappearing, right? There's no traditional way of, a gateway you can adopt to protect my serverless functions, to protect my namespace, because everything becomes like a virtual concept. So the parameter is changing. Then how about the security? It has to be changed to fit into that change. So what we learned is that security model is also improving a lot. Today, more and more security solutions are heading to the zero trust model. So I want to describe this in two ways. Like a long time ago, we pretty much in a reactive security model, which we're basically trying to protect the unknown parameters. We try to scan the known issues of the environment. We try to use deny list policies in the firewall, right? We try to figure out, hey, what are the bad IP addresses I should block in my policy? I can only scan all the known issues, right, on my environment. And I can, deploy agents everywhere on my dedicated physical server, virtual server. I basically buy the zero feed, security feed from third party, try to catch the bad, malicious software as quick as possible. I call this kind of reactive model. Basically, you can protect what you already know, or you can buy some time to get earliest security feeds or the CVE updates, right? But once the workloads from a trusted and trusted zone concept migrate to a cloud scale, this same thing as parameter, right? Every workload, every data will be treated equally in the public cloud because the resource was shared and was dynamically allocated. And a good indication is also the IP address. Before, you can have a bad IP address managed in your firewall. But now, in the microservice Kubernetes environment, it's so hard to track what's a bad IP address because IP address is all dynamically allocated, right? When the container came up in seconds, it will automatically get the IP address from the system, and it will just run the services in minutes or in hours. Then it goes away. This IP address will be released for another service to reuse. So the reactive model of security, it really doesn't fit. It cannot scale, cannot catch up the quick change. So that's why the new security model was introduced. We call it proactive zero trust security. So you cannot rely on a deny list policy to protect that because you cannot manually configure your bad IP address list, right? You cannot rely on the known CVEs to dealing with, runtime attacking. So what that model means is basically in the opposite protection method, you basically use a allow list policy, untrust everything by default, and you use a declarative way to define your application behavior, and that behavior basically is a deny list policy, right? By default, it's allow list policy. By default, everything was denied. Only the thing you declared are allowed to communicate, to talk to each other, and nothing will rely on the physical resources. No physical IP addresses will be defined in the policy. So this is a new way of doing proactive mode security. We also call that zero trust. because that's the most efficient way to scale in the cloud. That allows you to do the security automation as well as protecting, known and unknown, right, threats in the future. So that's pretty much the concept of zero trust security model. And thanks, Glenn. So for Raster, define this zero trust security model, zero trust strategy in these 7 pillars. I like it very much. What are the 7 pillars? Basically, you need to think about the security guidance around 7 major assets of your company. The first asset is going to be user. Yeah, you're going to have to make sure the user identity are secured. Then the device, of course, right? Every user has the security has devices. Then the network and the environment, right? And then the application and the workload. And then you think about the visibility and analytics of your security, events and logs, give you good feedback about what to improve. Then the last 2 are the automation and the data. Those are 2. We all understand that's 2 must-have piece in this cloud-native environment because everything was built onto the CI/CD pipeline. Everything will be automated, and everything will be highly rely on the orchestration platform. So all those 7 pillars are the entry points. You want to review your security postures. You want to review your compliance around that. So at high level, so what's the practical security practice, right? You should do as a start. So from security concept, what we should do is I basically put the 4 major points to protect those 7 pillars in the zero trust strategy. First one, you want to minimize your attack surfaces, right? Second one is you want to be sure you have enforcement at real time, because without enforcement, right? We all know that it's good you can do the post analysis, but the bad thing already happened, right? You want to have enforcement in places to make sure your production workload is secure, is safe. And then you want to have continuous visibility and compliance capability. That's super critical. As of today, compliance or security analysis, it's not just a snapshot. It has to be continuously monitoring, continuously alerting, because this container microservice Kubernetes workloads is automatically running all the time. It's growing, it's scaling. You want to have security also continuously monitoring that. And the last key point is security itself doesn't mean you have to spend many efforts to adopt zero trust strategy. And security can be invisible, can be transparent, and can be super easy to automate and use. Those are the key points I would like to share today. And we will look into some detailed functions in the next few slides. So then some of the customers was really working with us and thinking about, hey, how can I migrate to this zero trust security model? Then we can pretty much define that as 4 stages, around that 7 pillar assets. The first stage, basically, that's kind of easy, low-hanging fruit. Everybody should start to look at is look at the user and the visibility side of it. You want to understand, right? Identify your critical assets. What are the first thing you need to secure? Basically, are the user profiles, right? What are the projects and budget in your company which you want to focus on the most of the critical assets first? And of course, for example, the privilege identity management, enable the multi-factor, authentication. Those are the basic things. Whenever you go on the public cloud, private cloud, right, whatever platform, that's the first thing you will define. You will need to configure. Those are the kind of first step you can do in your migration to the new model of security. The second phase basically is, okay, now we have a user and the visibility into the system, user secured. How you want to take a look at your device, network, and the environment. Those are the platform, typically are the platform responsibilities. They're gonna give you a security checks, configurations to hardening the environment. Make sure you have a solid foundation to load your container workloads. For example, they may give you the some network connectivity configurations like public cloud access, the routes, right? The encryption of the networks, the encryption of your data storage. Those are also can be configured to give a certain level of security for device, network, and the environment. Of course, you know, you may need another tools to give you deep visibility into the environment. Like, hey, how's my container running? Where is it? What are they talking to in what protocols, right? Those are all critical visibilities into your environment, so you understand where is the scope to protect. Then the third phase is around your application pipeline and the workload. This really goes to the we call cloud native workload security space, and Gartner called that a CWPP concept. Basically, now you have the solid foundation, right? You can think about, okay, now I deploy my production grade containers, into the environment. I want to implement some, for example, micro segmentations. Make sure my container talks to the right person. Make sure network side it's only adopting the zero trust policies. It should not talk to anybody that's untrusted, right? And you can also integrate the security into the pipeline. This is a super important part because we all hear more and more about shift left security. This is all about build the security capability into your CI/CD pipeline, so you can find all the known issues as early as possible. You basically clean up your image even before it's being deployed into production. That's another big topic, but there are many tools available to help you to achieve that, include NewVector as well. So once you have applications, pipeline, workload, in a relatively secured environment and have the right protection around, the last phase pretty much is, now you can look into more advanced security configurations or security checks. Just for example, you can start dealing with sensitive information like data leakage prevention protections. You can do advanced network securities. For example, for some highly regulated industry, they may ask you to do IDS IPS for your internal communication. They may ask you to do the WAF protection for all the public-facing web servers, right? So all those advanced network security technology can still apply to your cloud-native workloads. There are technologies, there are solutions, available for you to adopt, right? Next slide, please, Glenn. So okay, so this one basically gives you some practical ideas, right? Let's see, there are many things I need to protect, but okay, what's the practical way to get started quickly, right? So as I mentioned in my last two slides, there are 4 key points, right, to protect your production grade workloads. So then let's go into a little bit detail about, hey, what are the functions, capabilities for those 4 key points? For example, how to minimize the attack surface, right? So that's basically, you can do a vulnerability management, you can do risk assessment, posture management on lifecycle. So you basically clean up all the security holes as much as possible. Then you can adopt zero trust security policies, deny by default. And as I mentioned, use a declarative policies to basically guard all the communication interfaces of your microservices. So all the entities are untrusted by default. Then you basically define what's the allow list in the security policy. Then use the least privilege access, right? Enforce the least privilege access, reduce your attack surface a lot, right? So nobody can really go beyond the limitation. Then talk about enforce in real time. This is super critical because it happens. We all know that hackers trying to get into your running environment, trying to do crypto mining, trying to do ransomware, right? All kinds of attacks, trying to steal in your sensitive information. So you need to enforce, right? Not just clean up the image, not just post analysis. You want to enforce the policy at real time, block the bad behavior at the runtime, and that's super critical, I think. So then you can have a comprehensive security enforcement implemented. You can inspect and block attacks at the network entry. Just give one example, right? When a network attack, that's typically where the hacking case happens at the beginning, trying to do the port scanning, get into your public-facing microservices. That's where you want to block at the time they're scanning the port, but not wait until they get into the container. That might be too late because it's already running in your container's memory, already using your CPU resources, right? Can cause potentially like a flooding of the resource usage, those type of damages. You want to block at the first entry when the hacking case happens. Then once you have a real-time enforcement policy in place, right, then you can basically enable the continuous visibility and the compliance check for your environment. You do deep visibility into the network behavior activities, right? Like this container is a database container. It should always just run, the database service. Why it launched malicious process in this container and doing something you never seen? That's already really, really bad sign. You want to continuously do the compliance check. Compliance has to be proactive model as well, right? For example, something changed in your network, in your process, file systems. A monitoring system should right away trigger a compliance check around that, but not wait until you manually trigger any checks to that. That's basically give you the best efforts to be able to make sure you are compliant all the time, but not just one time. Then the last one is, security, it has to be automated. We all know that when you scale out, you can scale out thousands of containers in minutes, in hours. Then the security cannot drag behind. It has to be automated in the same way, right? It has to be managed the same way as you manage your cloud native workloads. And it can be integrated into your pipeline workflow and all the analytical services on the back end. With all those, security functions, implemented, then you are in really good shape to have a full lifecycle security. So now let me hand off to Glenn, who can dive you into a deeper, capabilities, or even show some real interesting stuff to show you what works. Thanks.
All right. Thank you, Faye, for that great overview of Zero Trust. I learned a lot from that, and especially how to map traditional controls into a Zero Trust framework and to approach it from different phases. In fact, one of our audience members made a comment that migrating to Zero Trust is a much better way to put it than implementing Zero Trust. I like how you think. So remember that, you can't, there's no button you can push or lever you can pull to implement Zero Trust. It's a journey. And it is a new approach or a new model or way of thinking about security that affects certain technologies as well as people, processes, access controls, and things like that. So pick off the things that can make the biggest difference. Those, as Faye pointed out, would be user access. And then I would say real-time enforcement. So in the case of a hack, you have the capability of actually blocking that in real time. So what I'm going to talk about is SUSE's Zero Trust product line. It's really centered around the NewVector product, which is a container security platform to help monitor and enforce the Zero Trust controls that you would like to put in place. So at a very high level, I'll start with the SUSE Secure Zero Trust Stack. And then I'm going to dive into the NewVector aspects of that and point out certain areas that NewVector can help put in place those controls that Faye talked about. So we have the NewVector container security product, which think of it as a tool that can not only enforce very specific zero trust controls. For example, Faye talked about workload security and declaring the allowed behavior of a workload or application. So NewVector is able to enforce those types of behaviors. But in addition to that, it's broader in that NewVector is able to look at your pipeline to make sure that nothing bad gets into your pipeline. It's also able to audit the configurations of deployments in your orchestration layer, or if you're spinning up new clusters, to audit the configuration of those clusters to make sure that they're secure and enforcing your zero trust controls. So I'll dive a little bit more into NewVector. But before I do that, the SUSE Zero Trust Stack really has many products. So I'm just highlighting a couple of them here. Rancher, as the orchestration and management layer for Kubernetes, is going to be able to make sure that your Kubernetes clusters that you deploy have the appropriate RBAC controls configured. And then, of course, NewVector can help Rancher monitor those. In addition, both NewVector and Rancher support single sign-on, and that can then be integrated with multi-factor authentication, and you can create role-based access controls to also be part of your zero trust strategy. Now, at a lower level, the operating system level, we have SUSE Linux, also called SLE. There are other versions of it, one called BCI, which are minimal or hardened container image versions that can be used in your applications that present a hardened or a reduced attack surface. And that's one of the key tenets of that Faye talked about. With Harvester, a fairly new product from SUSE and the Rancher product line, it's really SUSE's cloud-native HCI solution. So it's leveraging advanced machine isolation technology to make sure that all of the organization's data is safe and isolated in the appropriate environments. So Harvester is also doing its part to maintain isolation. And then down at the data layer, the critical layer that Faye talked about, Longhorn is the storage solution that's integrated also with the Rancher stack. And Longhorn can implement encryption of data at rest. And in addition to that, the NewVector solution can ensure that data in motion in network connections, either between your application microservices or ingress and egress out of the cluster, are also encrypted so that the data is protected when it's in motion as well. So think of zero trust. Faye talked about it from people and processes and the 7 pillars. But another way to look at it is as the technology stack that you're using, and what role does each of these technologies play in a zero trust security model. So, and by the way, if you do have questions or comments, please feel free to put those in the Q&A box, and we'll get to those at the end. Now, Faye mentioned that things are moving so fast that traditional security tools can't enforce a lot of the controls that he talked about being required for zero trust. And specifically, one aspect of that is Kubernetes, and the networking aspect of it is really abstracting the network layer. So it makes it very difficult to apply traditional network visibility, segmentation, even traditional security concepts like WAFs and IDS-IPS. So what we need is really a new technology for that. And the reason this is so critical is because the actual, where workloads get deployed into production, where developers are creating apps, and then those are constantly getting updated. This attack surface is broadened, and it's also a bigger attack surface than previously we had. So the first is it's so critical to secure the pipeline to make sure that nothing unauthorized gets into your pipeline. And while RBACs and registry access is critical to that, it's also critical to make sure that images are being scanned all the way through the pipeline. But it's also critical that the security integrated into the pipeline doesn't break the pipeline or slow it down, because then we're back at the traditional waterfall, big monolithic app problem. As Faye mentioned, it can just be an accidental misconfiguration of any of these technologies in the stack that can open up an attack surface or a window for hackers to get in. So there needs to be continuous auditing and monitoring of all of the configurations, whether that's workload deployments or Kubernetes, RBAC settings, or the API server settings. Any of those need to be continuously audited. In addition, we've seen critical vulnerabilities of the orchestration layer. Kubernetes itself, the API server, has had critical exploitable vulnerabilities. So think of that as a new attack surface that you've got to be concerned about, in addition to just securing the applications that you're deploying. Any tool, whether it's Istio and a service mesh or your Docker runtime, Containerd runtime, could present an attack surface and a vulnerability. And then finally, the applications and the workloads, the containers running in production present an attack surface. And although microservices can be hardened, they still can have application layer attacks that need to be detected and prevented. There's still zero-day attacks that can happen even before a vulnerability is discovered and disclosed. So security does require really building it into the life cycle of an image or a container. And so we like to divide that into two major aspects: supply chain security and runtime security. In the supply chain area, it's important that anything, whether it's open source or other code that's being used in the workloads and being put through the pipeline, is secured. So vulnerability scanning, compliance, admission controls are critical as well to prevent unauthorized or vulnerable images into the runtime environment. And then once things are running in the runtime environment, runtime scanning, detecting traditional network-based attacks or threats. Those could be SQL injection attacks, cross-site scripting attacks, and the most recent Log4J attempted exploit falls in that category as well. So if you have in place zero trust controls, it's really the most comprehensive way that you can protect against these attacks, as well as the most scalable and automatable way. And I'll talk about how we do that in a minute. So another way to look at it is there needs to be full lifecycle vulnerability and compliance management from when the developer is building the image, putting it in a registry, and then also running that in production. Continuous scanning and compliance monitoring of open source, of vulnerabilities, of compliance issues, CIS benchmarks, compliance reports, and then in runtime, being able to know what's in the runtime environment. Now, once things are running, or actually before things are running, admission controls is the critical gate between the pipeline and the runtime environment. So that's a critical gate where we should take a look at some of the zero trust controls that can be put in place in the form of admission controls. But once things are running, the ability to implement these zero trust controls through a container firewall and container workload security, which will monitor all of the network connections and the process and file activity and be able to detect and block attacks, is the most critical real-time runtime security protection. Now, in the past, you had to, as Faye mentioned, put in a bunch of blocking rules and deny lists But in a zero trust environment, we're going to declare the allowed behavior of all those workloads, the network connections that the firewall should enforce, and the process and file activity that is allowed in those containers or workloads. And once we lock it down, that becomes your security zero trust control. And the way that we can make it work is through behavioral learning, automation, and security policy as code. So it's critical to be able to declare the allowed behaviors, update those allowed behaviors in the pipeline as developers are building them so that they can be programmatically pushed or declared into the production environment. So there's no need to contact the network team to request a port be opened or an allowed egress connection put in place and to delay the release of a new update. To make it easier, we can use things like behavioral learning, where you can just run your application scripts in a test environment, and a tool like NewVector can just learn and create all of those allowed behaviors for your workloads, which then you can check in as security policy as code and have a way to automate all of that, or expand it into multi-cluster environments. So some of the areas where the NewVector platform is unique is in the integration with automation technologies like CRDs, custom resource definitions, all of the network visibility, the packet level, deep packet inspection to enforce segmentation, and those allowed network behaviors are all areas that are unique to this platform. And by the way, it is an open source platform, so there's a preview version of it available on the GitHub/NewVector GitHub organization, as well as the images can be pulled from the Docker Hub NewVector organization as well. You can try it out yourself. But with the deep packet inspection engine, we can implement things like DLP, data loss prevention, and WAF, web application firewall technologies, which are often required for compliance. So, while it's important to do some of the traditional security activities such as vulnerability scanning and management, keep in mind that and trying to keep up with deny lists and signatures is really like looking in the rearview mirror. You're looking at past things that happened and trying to make sure those don't happen. And while that's important, it's not going to protect you from the latest zero-day attack. Or if somebody had discovered Log4j before it was published and a CVE issued for it, they could be exploiting your environment for months before this was even disclosed. So how do we make sure through things like traffic inspection and detection that all zero-day attacks can be detected regardless of whether there's a CVE available for it? Now, Faye already covered a lot of this, which is really comparing and mapping traditional security controls with zero trust controls. So on the left, traditional exception-based or deny list-based approach are listed here. And on the right, a zero trust environment really declares the allowed behavior. In this case, in NewVector, network process and file activity, but also user access controls. I'll talk about admission controls and how that could be configured to be a zero trust environment as well. Now, that's not to say that traditional controls on the left are not important or useful. They are very useful, and in security, you want to have as many ways that you can detect and prevent attacks. So a layered security strategy is always a good idea. And in fact, for compliance, some compliance regulations haven't caught up with cloud native technologies and security. So they still require things like WAFs and next generation firewalls to block or deny list IP addresses and malware scanning, even though those can be detected and blocked when you move to a zero trust architecture. I think the recent Log4J CVE is a good example to illustrate the combination of both traditional security controls as well as zero trust controls and where that would have fit in your security environment. So if we look at day 0, before the CVE was even known about, if you had put in place zero trust network process and file activity protections for your workloads, and one of the things the CVE mentioned was strict egress controls, because this exploit required a connection to a vulnerable LDAP server as well as a command and control. So if you had those in place and this type of exploit was in progress, you had a good chance of being able to detect it and potentially block one of those 3 or 4 steps in the kill chain of this exploit. Now, if we look at day 1 and after that, after the CVE was disclosed, we immediately put out a WAF rule to detect the exploit in progress, and which you could have applied to any container that was taking inbound or ingress connections to your cluster. Now, WAF rules are not fail-safe, but it's one layer of protections. You could have tried to automatically quarantine any container that was detected running with this vulnerability if it would not have affected your business logic. And then you would have put in place immediately admission control rules to block any scanned image that contained this vulnerable version of Apache Log4j. And then in addition to that, looking at where your exposure is in the runtime environment, and then going back into the pipeline to find vulnerable images that were in your registry, and then to put those back through your build pipeline to make sure that those get remediated and allowed to then be promoted to a production registry to rebuild those images. So here you can see that we're using a combination of zero trust controls as well as traditional security controls to detect and prevent the Log4j exploit. Okay, so let's see. So I'll give you a quick overview of NewVector. I'm not going to go too much into too much depth, but I just wanted to point out so you have some familiarity with tools that can be used where the zero trust controls exist and how they look compared to more traditional controls. So NewVector is a security platform. It is a set of containers that get deployed. You can deploy it through Rancher or on a native Kubernetes environment. And it's going to have a control plane, like you see here, just containers, scanners to scan for vulnerabilities. That can be scaled up if you have a large number of images. And then enforcers, which are going to be deployed as a daemon set. There's another 1 container per node, which is going to be inspecting all the network traffic and doing all the real-time zero trust controls. So with that infrastructure, we're able to start scanning all of the containers. That's more of a traditional control. We're able to demonstrate and visualize all of the network connections that are occurring in your environment. And you can see it can be a very complex environment with a lot of network connections. The connections in blue are the ones that have been allow listed, declared to be authorized connections, and these are layer 7 connections. So the protocol is being confirmed and validated. So this is really your segmentation, zero trust segmentation. Any connection that is not allowed or any embedded network attacks would start to show up with red lines. And any of these can be expanded. So in this case, there's a connection going to an external IP address, which is not allowed. In a very complex environment, it can get complicated very quickly. So you can filter by namespace or protocol, or only those that you're really concerned about your application workloads. So here's an example of, we can see connections between Nginx and Node. We can see that in this case, we do have a service mesh that's encrypting the traffic as it goes between the pods and the demo namespace. So we can see the Istio proxy there. But NewVector can still inspect all of the network traffic and enforce those zero trust controls and look for embedded network attacks, even though the Istio proxy is encrypting the connections between pods and decrypting it on the other side. So as I mentioned, one of the key gateways between the dev environment and the production environment is admission controls. So once we have scanned images in a registry and detected vulnerabilities, we can also then set up some admission controls where we can allow or block deployments into my production environment based on certain criteria. Now, some criteria are based on more traditional controls, like if it's got certain vulnerabilities, in this case, the Log4j vulnerability, I'm going to block that. But you can also implement what we would consider zero trust type of controls with admission controls. So for example, if you define a trusted list of production registries, and those registries have RBAC protections and protections to only allow scanned images that pass into those registries, we can further narrow the scope of deployment to only allow deployments from these trusted registries, or don't allow unless they're in our trusted registry list. So you can see that it is possible to implement zero trust controls as well as traditional security controls in tools like NewVector. You can use you can use labels to also implement zero trust controls. You can specify owners of images and allow or block based on owners, as well as users and user groups as well. So very flexible to implement both traditional and zero trust controls. Now, if we go to the runtime protections, we can see that in every container deployment, NewVector is going to monitor all of the connections of the pods in there. And there are going to be a set of network rules. This is the allow list that Faye talked about. There's going to be a set of processes that allowed. And if there are file act specific allowed applications, those are going to be defined here as well. And once you have locked down this environment, only that behavior in the Node.js pod, those network connections, those process and file activity is going to be allowed. In a monitor mode, NewVector will just alert, and in a block or protect mode, NewVector will block those connections. And here you could see more traditional controls. DOP is going to inspect packets for credit cards and social security numbers. And WAF sensors are going to look for things like the Log4j exploit or other types of WAF-based attacks. And because we're inspecting the connections, and this can be on inbound or outbound traffic, this capability can be also used to implement kind of a zero trust framework for API security. So you can specify what type of connections a pod is allowed to connect egress to an API service, what protocol needs to be used, and even what needs to be in the header or in the URL of that API call. So here you're restricting the workloads capability to a very narrow definition, which we would call a zero trust definition for that workload to access that API service. So a lot of great capabilities in here to implement both zero trust as well as traditional security controls combined. So just to wrap it up, and then we'll see if we have some questions. When you're moving to a zero trust framework, and especially getting down to the level of implementing controls in your container environment, a zero trust approach will declare those allowed behaviors. We talked about declaring through your pipeline, through those CRD YAML files, the allowed network connections, process file activity, but you can also declare the admission control rules or the DLP rules or the WAF rules that are allowed. Don't assume that any type of security, not just Zero Trust security, is built in if you're using a public cloud service. There's a good article that AWS publishes on the shared responsibility security model, where you as their customer are responsible for your data, your network connections of your workloads, any egress, ingress connections, and any other tools that you're using that could be an attack surface in the environment. So you're still responsible for a good part of that security. In order to be practical, Zero Trust security must be automated. You can't be running around adjusting the allow list every time your workloads are going to be updated. And as Faye hammered home, you need to be able to continuously audit the security in the stack. And that could be RBAC configurations in Kubernetes. That could be running the CIS benchmarks across the API server, the nodes, the Docker runtime, or the images in your pipeline as well. So everything should be continuously audited, because after deployment, somebody can declare a changed state of your cluster, and that could inadvertently open up an attack surface. And so there needs to be alerts that happen if that should occur. All right, so I hope you've enjoyed Faye and my overview of Zero Trust and the SUSE secure stack. Why don't we see if there are any questions? Cody, do you want to help us out with that?
Sure do. So we have received a couple questions. This first one reads, does NewVector require agent to be installed in a pod so that it can monitor the Kubernetes cluster?
No, we don't. You saw there when NewVector looked at one of my application pods, there was an Istio sidecar proxy in there, inserted in there to run the service mesh. NewVector does not require anything like that, like a sidecar proxy or any other workload agent. There is one NewVector container, the enforcer container, that gets deployed, and there's one on every node. And from that vantage point, we're able to do all the packet inspection and Zero Trust enforcement.
Perfect. So we did get another question, and it reads, does your tooling, the entire range of tools, work with Windows containers as well as Linux containers?
That's a great question. I must confess I'm not an expert on all of the products in the SUSE stack. I know that some of them support Windows containers and some do not at this point. In the case of NewVector, NewVector does not support today Windows containers, but it is something we're looking at for the roadmap.
And I want to emphasize that, also answer on the chat window. When we say we will not support, which means we're not 100% support, but we do have some coverage on the Windows containers as well. For example, we can do the pipeline CI/CD scanning. We can do the vulnerability management. The thing doesn't work today is basically runtime network security policy. That doesn't apply to Windows, because everybody knows Windows is so different from the typical, virtual networking design.
Yeah, thanks, Faye.
Great, thank you. So what's the difference between Zero Trust and a secure supply chain?
Well, I think it's basically looking at the similar issues from different angles, right? The supply chain issue is pops up. I mean, recently is because when you look at the source of the components, the source of the building materials, people realize, hey, you can really clean up your pipeline, clean up your building libraries as early as possible to really minimize attack surface for the future. That's about supply chain. And of course, it's not just same thing. It's not a one-time thing. I always try to emphasize it's continuously a job, security job. You want to make sure the whole pipeline, the building pipeline, all the way to runtime, you want to continuously check everything, make sure it's in the good shape, everything being patched correctly, right? That's a supply chain view about the security. But when you talk about zero trust, actually it's part of the story, right? It's a similar story. But you think about zero trust is really get into this from that 7 pillar assets. From that angle of the view, how you can practically, use all kinds of security technologies to secure, include the pipeline, production, include the runtime, or even the post analysis. So it's just a different view angle about similar security issues everybody has to face, right?
Yeah, just as an example, so secure supply chain can be part of a zero trust strategy, but at the same time, you could use zero trust controls like user IAM access controls as part of your secure supply chain implementation, right? I mean, having the proper access controls into your supply chain tools is a critical aspect of both supply chain and zero trust.
I saw there's new questions about is NewVector available as a PaaS offering on AWS, Azure, and GCP? Glenn, you want to take that? Since I'm reading the questions.
So NewVector is a container that's deployed, either Helm charts, Rancher, kubectl commands. So it's really a layer, a security layer that can be on any Kubernetes cluster. And so many of our customers are financial services. They're running Kubernetes on-prem or government that require an air-gapped environment, and NewVector just deploys there. If you're running in the public cloud, NewVector can be deployed on your environment, or if you're running a PaaS environment, you can use NewVector as one of the layers. But the actual NewVector product is not, so to speak, available as a SaaS or PaaS product.
Yeah, this reflects to the one point I made. I think NewVector solution is kind of like a transparent security for you, which means doesn't matter what kind of PaaS you were using. You can even use multiple clouds, right? As far as the Kubernetes clusters, grows, NewVector can just, lay a security layer on top of that. Just be transparent to protecting all the clusters for you.
Yeah. A couple other ones I'll pick off. What about AMD versus 64 versus ARM or Apple Silicon? So currently supported on AMD, of course, 64 Intel-based architectures. In the roadmap, as we move to more edge and IoT type of security deployments for containers, that's on our roadmap as well for things like ARM. Apple Silicon, not today. We really, most of our customers are going to use NewVector in a, kind of pure Linux Kubernetes cluster environment, and they may use a little bit of testing on their laptops with Apple Silicon, but it may be something that we support in the future. Is it based on eBPF, which Linux is recommended? So we support all of the commercial Linux distributions. We're not reliant on eBPF, so don't worry if you're using an older version of Linux. All of the network stuff that we talked about is our own packet filtering technology that we own and have a number of patents around. The process and file activity monitoring, sometimes we do use eBPF if it's there, but if it's not there, it's not. We don't rely on it for enforcement.
Good. I want to add one more point for which Linux is recommended, right? I do recommend the SUSE BCI base image. The reason is just that, for the highly restricted, environment, BCI is the one base image that passed the FIPS certification. That's a high standard certification that you want to get that if there's a chance, right? That's that's one. Of course, as Glenn mentioned, NewVector itself really, is on top of platform. We support any popular Linux platforms as far as you use that. You can use NewVector on top.
Yep. And then another question, can we integrate to SIM and SOAR systems? Yes, definitely. NewVector is really designed to be more stateless, like Kubernetes. So you saw in the console that you can see a bunch of events happening, but really all of our customers would integrate NewVector through syslog, webhooks, or other like Splunk integrations, IBM, Security Advisor integrations into their SIM or source systems. And you saw from phase 7 pillars that SIM or SOAR is a critical aspect of Zero Trust.
All right, well, Faye and Glenn, this seems to be all the time that we have for today, so I'm going to have to cut you short before we get to any more questions. But I really appreciate the both of you taking the time to be here and putting together these presentations and really showing us the nitty-gritty of how the platform works. So thank you so much for all the work that went into this.
Thank you.
Yeah.
Thanks, everyone. Of course,
Yeah,
any more questions, please feel free to contact us. We can definitely talk with you offline. Many questions, please feel free to send to us.
Yep. Have a great day, everyone.
Awesome. And just a reminder to our audience that the session was recorded, so you'll receive an email shortly after we conclude today with a link to access the on-demand. You can also rewatch it on the Security Boulevard website at securityboulevard.com/webinars and look in the on-demand section. So we do still have those 4 $25 Amazon gift cards to give away. Our first winner is Victoria G. Our second winner is Martin K. Our third winner is Caroline K. And our fourth and final winner is Kristen E. So congratulations. Keep an eye on your inbox to claim the gift card. And if you don't see an email, just check your spam folder. I would like to thank NewVector for sponsoring today's webinar. And of course, my final thanks goes to you, our audience. We really appreciate you being here with us today. Please take that just an extra moment to fill out our post-webinar survey. And we hope to see you at an upcoming TechStrong Learning webinar. Thank you all so much and have a great rest of your day.
Thanks, everyone. Bye-bye.